My name is Mark Heiner. I'm an ImageJ2 developer here with LOCI. And a big focus, as Curtis talked about with ImageJ2, has been on interoperability with other applications and having a general framework that we can interoperate. I'm going to talk to you today about that effort with ImageJ and MATLAB. So there's a history here because ImageJ and MATLAB are both very popular scientific tools. They're both very useful. And so it makes sense that people have wanted to share algorithms or routines written in one have those operate on data structures in the other. So this actually started with a project called ImageJ, and that was just kind of a basic, simple Java bridge that allowed you to start up just core ImageJ inside of MATLAB. And so Fiji came along and kind of expanded that with this ImageJ project, which is just another startup script that you run inside of MATLAB. And so what you get then is all of Fiji plugins instead of just the basic ImageJ installation. So that was necessary because Fiji took some extra, added some extra complexities in how it starts up and loads its plugins and everything. So then ImageJ2 came along and we changed kind of the way that the whole application starts up. And this basically built a wall between Fiji and MATLAB. And so even with use of ImageJ, we basically broke it and you would only get your standard ImageJ inside of MATLAB. So certainly we had to, at the very least, fix that and get Fiji working again. But we really wanted to also kind of take advantage of the flexible new ImageJ2 framework and go beyond that. So the software I'm talking about today is ImageJ+MATLAB. It's on an ImageJ+MATLAB update site. And I want to emphasize that the ImageJ name is very Fiji-centric. And so this is a deliberate kind of generalization. We're going back to ImageJ. We just want to start up ImageJ inside of MATLAB or communicate with ImageJ and MATLAB. And so if we happen to have a Fiji installation, you'll get your full Fiji installation, but you can use it with just ImageJ2 as well. So this update site contains an ImageJ startup script. So you just say ImageJ inside of MATLAB, and then you get your ImageJ running. Converters are a really special type of plugin in this powerful ImageJ2 plugin framework. And what they do is they basically let you tell the framework that two different data types can be converted between each other. And so the converters actually implement that logic, but it's like registering with the framework that you can now use these two things interchangeably. So ImageJ+MATLAB provides converters between MATLAB matrices and ImageJ images, specifically ImageJ2 data sets. And another plugin type provided by this update site is Matlab Commands. And so these are ImageJ provided basically utility methods to import ImageJ images into MATLAB to convert them as matrices. So these are like the ways you expose those converters to users. You actually interact with the MATLAB commands. And these are also plugins so that anyone can drop in new MATLAB commands and they will just become available because of this framework, this ImageJ+MATLAB bridge. And kind of the most interesting thing here, I think, is that you can also now write MATLAB scripts inside of the ImageJ2 script editor. So this is kind of bidirectional now. You can use ImageJ2 inside of MATLAB, and you can use MATLAB inside of ImageJ. What this actually looks like from the MATLAB perspective is, this is very similar to ImageJ if you've ever used it. You have to tell MATLAB where to find your startup script, and then you just say ImageJ, and then you get your whole installation. You get Fiji in this case, because this is running with a Fiji installation. And what I want to focus on here is that these are the MATLAB commands. These are plugins, and then the framework is taking care of doing some extra work, like printing out what commands are available to the user, creating a MATLAB data set, workspace object for the commands so that it retains those commands. And then, but this is still basically just business as usual inside of MATLAB. We're just converting ImageJ2 images to matrices. And it's still useful because, so you might notice it's grayed out, but ImageJ is still present. You still have the ImageJ utility methods for importing ImageJ1 images and results tables. But if you wanted to use a command inside of Fiji that opens specifically ImageJ2 data sets, perhaps something that's n-dimensional, for example, 6-dimensional here, you can then use these new ImageJ+MATLAB commands and import them as you still get a 6-dimensional matrix inside of MATLAB. From the other direction, from the ImageJ perspective, so this is the ImageJ script editor. This script is pretty simple. It's just going to create a mask from this image and dilate it and apply it to the original image. And if anyone's interested, the script is a template that's available inside of the script editor. But what I want to focus on here are these @parameters that Curtis was talking about. So Curtis said they talked about them in the context of modules, and you can also use them inside of the script editor. So here is an @matrix, and so that's something special provided by ImageJ+MATLAB that's saying, I have a data set, and I want a MATLAB matrix. And so just by declaring that as an @matrix, the framework uses the converters behind the scenes and does everything implicitly. And then in the other direction, because this is a MATLAB script, it doesn't know about ImageJ2 data sets, but by telling the framework that we want these matrices out of the script as data sets, those converters will be called again, and the whole script framework will just automatically convert them back to data sets and then display them. So just to summarize what everything looks like together, so the lowest level, the space level, this foundation that we're providing are the converters between matrices and data sets. They are exposed in MATLAB through Matlab Commands, which are also plugins, and they're exposed in ImageJ through @parameters, which are picking them up automatically. And all these are plugins, anyone can add them for your own data types, for example. So as for what's next for this project, well, we could add more converters, we can add more commands, more utility functionality, we can add more useful scripts demonstrating how to actually use this inside your MATLAB, how it benefits you as a user. It's really just up to you, so turn on the update site, give it a try, and let us know what you need. And if you want to start developing your own converters or plugins, we can get you started with that as well. That's everything. Are there any questions about this work? Yeah.
Converters,
Yeah.
do they work without the core data? Do they make a new copy of the data?
So it depends. It depends on the implementation of the converter itself. So in this case, between MATLAB and ImageJ, you do have to copy the data because, so MATLAB's Java-based. It has if you're running inside of ImageJ, you actually have 2 separate instances of Java running. So you have to copy the data and pass it over to MATLAB to operate on, and then pass it back. But that definitely would be a way to investigate, optimizations to avoid copying, because that's not desirable, right?
Yeah,
In general.
Exactly, that's why I was wondering.
Yeah. So right now, this is kind of a first pass, just get everything working, and then let's optimize together based on what people need. Yeah. All right. Oh, yes. Yes, exactly. They are converted by double arrays, and that's an implementation detail of the library that we use. It's called Matlab Control. So it's an open source library that's used for passing any data to MATLAB specifically. All right. Thanks again for your time.